Welcome everyone to the June edition of the Building Operators Association of Canada monthly meeting. And as you're probably well aware, since last September, we've been doing these Zoom meetings to try to reach out to our membership in lieu of in-person meetings. You know, with the way things are going, I'm always very hopeful that maybe perhaps maybe even in September we'll be able to start the in-person meetings again, which will be most welcome. And I guess from what we've learned from doing these webinars, we'll probably be doing, we'll still be recording our meetings, and maybe we'll get a little bit more, as far as guest speakers and stuff, we can still do remote guest speakers and still utilize Zoom during our regular meetings as well. And so we're over the summer, we're going to try to equip ourselves with some of the more technical stuff, different cameras and stuff like that we can use to record our meetings. And so the future looks interesting, that's for sure, a little bit different, and we will just sort of move along with the times. For those of you who did not get the magazine through email, you can go to our website, which is www.boacalgary.com, and download a copy of the magazine. And in there you'll see articles, information on our sponsors and stuff like that. And so we put together a pretty good little magazine. We have for many years, and we're keeping that going, and hopefully more people will download it and take advantage of some of the resources that you'll see in the magazine. And perhaps even Luke here will contribute to the magazine in the future with articles and stuff. But anyway, our topic for this month is going to be control valves and what you need to know. And so this is sort of certainly over the years been a passion of mine, not only as an operator, but also in the automation controls business. So I was heavily involved in valve selection and stuff like that, and design. And so I know probably, a fair bit about it, but also I also know that you never know enough, and especially when you're getting into retrofitting buildings to upgrade them, and there are some opportunities that you can take advantage of if you're aware of some of the products out there that are designed to help you, or designed to help the thermal comfort of your building. And so so I'd like to introduce Luke Chamberlain. Luke is the I guess your official title is what, Canadian Sales Manager? But anyway,
yes.
But he is the one of the technical control valve guys at Spartan Peripheral Devices, and it's not very often that I give companies my personal endorsement, but I would say that I've been using Spartan valves here and there since 1998. So there you go. I know a little bit about their product line. I know a little bit about the company, and and it's been a good experience. And I guess probably what the biggest thing for me was with Spartan was that they use um, conventional valve bodies rather than cheap.
Rebranded.
I'm not going to say the word. Some of the less expensive valves that you'll see out there are disappointing, as in that they don't have that long of a life, and they cause problems for operators. And so whenever you have the opportunity to put a proper globe type control valve in, you're way better off from a maintenance point of view and a performance point of view. So that's my take on that. Luke is, I guess you've been with Spartan for 10, 11 years, whatever, a while.
I'm a part of the furniture, but I mean, in the HVAC field, yeah, I've been there 15 years.
There you go.
Combined with the instrumentation background and control, but it was more on the industrial side. So everything related to buildings, I've been involved with, from the duplex plug to the breaker to the ballast lightning system, which will be a bit part of the wireless section that we will speak later on.
So we might as well get it out of the way, probably by everybody's come to realize by your French Canadian accent that that you are from Montreal or thereabouts.
Correct. Spartan Peripheral Device. So we just give a little idea of where we come from. Is based out in Vaudreuil-Dorion. Most people will spell that wrong, but it's all good. You know, I was raised by an Irish mother and a French dad, so I got the works of both sides, you know. But in any case, to make it short, yes, we're a Canadian manufacturer, and we're quite proud of it. Throughout everything going on right now, Spartan has been designing and producing, manufacturing its valves since the late 80s. And I mean, our design is there to remain. As you know, there are many types of valves out there, Mark, such as butterfly type, you have the ball valve type, but we're specialized in the globe type. If you want control, it's all about the globe style. You know, it's to every valve, there's an application. I don't want to discredit any product. Depends on your budget or your expectations. But as far as I'm concerned, for example, I would not specify as an engineer a pallet valve, such as companies I would not name. But, you know, when you get to a service call with a problem of close off, and you realize that the valve will only give you like 6-7 pounds to close the flow. Therefore, you're having a challenge there. But whose fault is it? It all comes down to the proper valve, to the proper application. So in a commercial building, as you've mentioned, Mark, before, I mean, the globe style would be the best if you're out to maintain and sustain a LEED rated building. Because most companies will tell you, okay, you install that, but there are so many problems that can be pinpointed inside a single building, but most of the time, it's either the heating system or the cooling system. So step one for a technician or building operators like you guys are, I mean, the best advice I would give you is the the heating system or the cooling system? Are you having a problem with overheating in the place? If it's the case, you have a shut-off problem with your valve. Your valve is not shutting off, so it keeps on heating. But if you're in a cooling mode and they're complaining about the heating, well, therefore the valve is stuck close. So that's a thing that, you know, needs to be asked to help you guys to pinpoint the problem, troubleshoot the situation in a prompt way, and make the end user or building owner happy. Because most of the time, that's the mistake that I can mention, that those technicians could, you know, a quick list. Problem, what's the problem? Number one, overheating, not cool enough. Number two, is it a problem with the thermostat? That's a different ball game, depending on the control, the close off, anything related. But the first thing, if it's overheating, not cooling, check the valve. With a globe style, the advantage, you just release the actuator, and therefore the internal piston will let you know that the valve is either open or closed. I don't know if I'm putting that correctly. Let's say you're overheating. It's because you're having a shut-off problem. Could be a debris stuck here. It's one of the things that I've seen in previous projects, large-scale projects. But the thing we did to fix that problem, we designed specific flushing caps. So you remove the internal cartridge from the valve, you do the mechanical portion. After that, you install a cap, which will allow you to do a full flow flushing. So there's no restriction between the inlet and the outlet on the other end. Because most of the time, when you're dealing with a globe valve, there will be a problem if the system is dirty, not flushed properly. Most relevant case would be pinpointed when there's a low CV. But you know, the mechanical or the plumbing contractor avoided to flush the system full port. And this is a thing we did to help maintain a sustainable building. Because if you were dealing with a ball valve, let's say, a ball valve would be a ball rotating instead of a piston coming up and down. So if you have you know, with the profile disc, sometimes you can have issues, especially when low CVs are involved. And what do you do after that? You're not able to fix it. In our case, the worst thing with the globe style would be to either you're packing, that's replaceable, which helps to you know, sustain a building. Because I've always believed in preventive maintenance, as I've learned from the field. Check on your system and you'll have good results and no complaints, and you're always busy, you know, to find the right way to maintain the what we called in our field comfort zone. Because the comfort zone is what the end users are looking for, the building owners, because there's many things involved in that to reach that level where everybody's satisfied. But there's always be things to consider, whether if it's the window, the sun pounding on the thermostat, and making the room so cold that people think the system, the heating system ain't working anymore. It's all these small features in a room we need to always look at. But as far as the control valve is concerned, you'll find many types of valves out there. Let's go a bit on the control side. But no, hold on. We'll go on the mechanical side, because that's the important thing. If the valve needs to be replaced, you go out on a service call. What do? You look at the valve, you scratch your head, and you're like, oh boy, what brand is this? What generation, what year? Because in many buildings, what I've seen in 12 years at Spartan is that there are many different manufacturers inside the building you guys will be working in. And first thing you need to find out is the manufacturer. So it could be, you could run into a older system like that, pneumatic system. You can recognize them with their round shaped head, similar to, you have bigger size, they will look like a beer can a bit. But yeah, it's one of the way we talk about them in the field. You can also have the plated shape version. So that would be a first control type that you will find. But where I want to come into is those flare connections. So if you see one of these, what you'll be most likely recommended to use would be a valve that was going to be NPT threaded both ends. But to go from a flared connection, something NPT, I mean, it could be thousands and thousands of dollars in plumbing involved. So what we did at Spartan, we have different types of valve. And as Mark said, the globe style is really a sustainable and long-during product. I mean, a globe valve should be installed and last as long as the installation, the piping is there in place, the original installation. If there's a problem, it's either going to be the internal packing or the actuator, which we'll go over very shortly. But when you deal with a situation where the piping is a challenge, that's your first question. What's the mechanical portion involved? Do I have a female threaded valve? Do I have a flared kind of valve? Do I have a male union like this one, which is quite popular with brands like older Honeywell or Danfoss style? Apart from Spartan and these two, I don't have much in mind that will produce the same in North America or have stock. Not to talk about other players from overseas. In any case, the challenge is to find a proper connection. I mean, we have different types of connection, whether if it's female inlet, male, you might run into PEX connection as well. So it's really all about the design. You know, it's based on a flat face design, and it gives you access to any type of unions you might need. So you don't need a PEX connection. You could go solder or NPT threaded. And globe valve should be, I mean, giving you an option to make those things simpler than they are right now. So, and we have double union. I mean, angle valve is something you might run into a lot as well. So the angle valve, basically you'll find these Sometimes you'll have a chewing gum sticking here in classrooms. But most of the time, one thing I can mention, a problem you might find that it's not hot enough in the place is that the insulation is made like that. This is a thermostatic actuator. We call it self-acting. So you need no power to bring to it. It's really a bullet with the gas inside of it that will expand or decrease with the delta T changing, or the change in temperature, if I may. So therefore, the problem to fix that would be to use a model with a bulb related. You can stick that in the bottom of your cabinet. And that's a very common complaint that I've pinpointed out throughout the years from past experience, especially when steam is involved. Another thing to consider is the medium. What kind of medium are you using? Is it a glycol mix, chilled water? Is it a kind of special application with chemicals for agriculture or anything related to that? So it all comes to the application. But I'm sure you guys, there must be some commercial buildings based on agriculture in Alberta, I'm sure. Throughout the experience I've made in the past SciFX West shows, I mean, you guys know a lot about controls, and I was very impressed that all the buildings for the animals were based on modulating control, which is another side of the things to be considered when you're on a service call. So after that, when you go to the control side, since we've covered the mechanical portion, which is important, the medium, because if it's low pressure steam, you better be sure to be using the proper type of cartridge. We've designed a cartridge in the globe style, because what's going to happen, medium of steam being very harsh with the raw material, you need to have the proper EPDMC, because when it starts to leak, it's going to blow out the control portion side. So if you don't have the proper valve for a steam application, you will know pretty soon. It might last a year or two. I've made many trade shows throughout Canada, and I was proud to be representing a product that will last on steam. But it all depends on whether if you have the nickel-plated cap. If you don't, good thing you have a globe style of valve, because the packing can be replaced. You don't need to replace a valve, because when you blow out the controls on the ball valve or a pallet valve, which I would not recommend on the steam application, yeah, that would be your best option, being a building operator. So let's go on.
One thing maybe that you could cover there, because you briefly mentioned it, is just a little primer on CV or flow coefficient. Yes. You know, for those of, well, there will be some of us that are new to the trade, and so and probably don't really understand what it is we mean by flow coefficient. And also I just wanted to point out when you were mentioning you know, particularly other control valve manufacturers products that you'll see, particularly in residential, that are European products. In Europe, and I know this from experience, in Europe, they use lower CVs. And the reason why they do is, or reason why they're able to do that is they design their piping systems a little bit different than what we do here. And also they're very meticulous about cleaning their systems. So you'll find that European valves usually have a CV range that's much lower than what you'll find in North America. And so in North America, I know that Spartan with their 1/2" and 3/4 valves have a standard CV offering. That you sort of come up with a happy medium. But maybe what we could do is just talk about CV, why it's important. I guess we don't really need to go into how it's calculated, but other than to say when a controls application engineer is laying out a building, what they do is go through a calculation process to determine what CVs are preferable for any particular valve location or system. And so CVs are important. What happens is when valves get installed, you have a plumber running along in the building with a bucket full of valves. He doesn't look to see which one has a CV of what or what, and one is supposed to go in a certain location and one isn't. He just goes around putting the valves in. And so sometimes in a building, you'll end up with in a brand new building, and you think, my God, what's going on? And then so you ask the guy, well, where did you put these valves? Each valve is tagged with a certain location, and there's, because it's a calculated flow for that location, and all you get is the look, and then you go, oh my God, how can I fix this? So then you have to go around and
that when the back and forth starts.
So anyway, the importance of CV, I guess, is a flow coefficient. Is the smaller the CV, well, I'll let
the
you
less
explain.
flow you're gonna get. And a quick reflection I can give or tip to you guys on that. When you're calculating a CV, most important thing you need to know is the flow, the GPM, whether if it's a fan coil unit or a rad itself. When you have the flow, whether if it's heating or cooling, you can calculate the appropriate CV. I'm sorry. So the formula is quite simple. I won't go in depth with that. Quick tip I can give you: when you're sizing a heating job, you take the GPM divided by 2. That's the way you're going to use a 5 PSI pressure drop, which is the best the ideal world for heating. With a 5 PSI pressure drop, you're going to reach the max efficiency of your valve, especially if you're modulating. There is the importance of sizing the valve correctly, because I've been taught by my mentors at Spartan that when you're using too much of a large CV on an application, just imagine a metal sheet, round metal sheet. You just saw a hole in there, and if you're half the way through with the flow, your valve is going to work up and down. But from here to here, nothing's going to happen. So this is why sometimes you're going to walk in a building, oh, it's not modulating. What's the problem here? It's a CV related problem, because they match, most likely, most of the time that I've seen throughout past experience, is the matching the pipe size. because back in the days, it was an on-off type of control. Then the controller world came in and the BAS system. So therefore, we all became like the underground heroes of their the daily lives and comfort of everyone. If the valve is not closing, the valve is not opening, we'll be getting a call. But with the BAS being involved, control types, different control types, when replacing a valve, the first thing to consider once you figured out the mechanical portion is whether if you're dealing with a pneumatic type of valve, which will come with a tube bringing air, therefore making the valve open and close on demand. Something that I'm sure you guys run into, and I want to spend a little time on this. It's the Thermoelectric type of control. So it's a 2-wire, similar to the, I mean, it's the same thing as the on-off type of actuator that can be found, but which is electric. Difference between the two of these guys, they both have 2 wires. The one will open in 20 seconds, the other one in 3 minutes. Difference, you have gears in this one. In this one, it's quite particular, and it's very old. It's from the basic of HVAC, and such a reliable product. Well, when it's well maintained. I started at Spartan in 2010, and I've had calls last year for units that were installed in 2001. So I was quite impressed. The way it works, there's no gear, so that's quite an advantage feature you can find with these. Similar to the on-off, so you have 2 wires compatible with most thermostat, can also be pulsed with the guys that would be more involved on the control side. So to simplify pulse width modulation, you put the power on, it's gonna try to open, you remove the power, you put back the power, but every control guy has his recipe to as far as the pulse width modulation, time to power up the unit to open and close and maintain that modulating comfort zone. It's all about getting that temperature stabilized and to the perfect point, or the comfort zone, as we call it. But the way this thing works, I wanted to show you, because it's quite interesting. As I mentioned, there was no gears. So we have an internal pellet filled with wax inside the actuator. It's right in there, and when you power it up, the wax being heated by an electric element. Therefore, that's the electric element. Hold on. So yeah, it's really a something that's been around for many, many, many years and still quite used and specified. Great feature, you don't have any noise. So you have the wax expanding or retracting that will make the valve open or close. Because most of the time, from a past experience, there was a big design made modulating by some other manufacturer I won't mention, that were installed in dorm rooms. But all the valves were located above the guy's head. And it was a government college, and there were many, many complaints. And It's close to where we're based out, just outside Montreal. That's how far I can go, as far as I can go. But in any case, we fix the problem by supplying thermoelectric actuators because they didn't mind if the valve would take 3 minutes to open, 3 minutes to close. Important thing was to the room to be quiet. But sometimes when it's space where people sleep, I mean, you will hear any brand, any manufacturer, you will hear that valve modulate to find that set point and maintain the room's temperature as per the requirements of the control guy.
Yeah, I'll mention it's very good for residential applications because number one, it doesn't take up much space, so it'll fit in a radiation cabinet. And also it is not noisy. And the only thing that you have to remember when you're troubleshooting it is you have to wait 30 seconds for the action. So that's actually a good thing. And in the controls world where you don't want any rapid changes, that they work very well. And I know that there is, to mention a manufacturer that I used to work with, Stafa, they've had thermic valves around for over 30 years.
Yes.
And the same valve actuator still working.
Yeah,
So
yeah.
there you go.
I mean, when you have the proper valve for the proper application, you're in business.
Yeah.
I mean, but some design or just, I find, copied and paste. And this is why, it's important to teach others to, question about the design. And if you have a problem, you could just replace the valve, but you have to go further than that and find out why you need to replace the valve. Because sometimes, just changing the actuator head, it's gonna be the same problem in 6 months. It's not the way to do it in my book. I mean, as a guy that's been involved in the field, most common things I've seen was the wrong valve for the wrong application, especially when steam was involved.
Yeah, so Les is raising his hand here, so there's something you want to interject with, Les?
I did. I had a question, is that I know that ASME has a lot to do because building operators deal a lot with pressured systems. And I know that ASME, whether it be follow the guidelines for installation of pressured vessels, whether that be Aziz Kassasi as the chief inspector in Quebec or Mike Coleman here in Alberta, when we put together these systems, do ABSA or does ASME make recommendations as to the type of valves to be used in these pressure systems?
In our commercial field, it's quite rare that we would go above 100 psi steam. Most of the time, it's low pressure steam, especially involved in commercial or residential buildings. Most of the time, I would go on the industrial side for these type of application. But as far as regulation is concerned, throughout Canada, I think apart from the ASHRAE and the other recommendation or the engineers association, there's not much, watchdog to check on these things.
I think what Les is looking for here is, so ANSI, which is, I'm trying to think of what ANSI stands for and I can't remember.
It's like a pressure rating. Yeah, really, it's like a PM number. So ANSI rating, because you have so many types of ratings out there for the valves, whether if it's stainless trim bronze trim, stainless disc. Yeah, but ANSI 125 would sustain less pressure than an ANSI 250. Most commercial valve will be rated 125, but the best would be 250, so you ensure you get a long-lasting product. Another thing I can mention about the NC rating that I've seen throughout the experience would be when there's a high zinc or nickel plated valves. What happens often is that the globe valve seat will become pitted at one time. It will become like a Swiss cheese, depending on the medium use. If you're using like, let's say 70% glycol instead of 50, over the years, you might get these results, especially when you're having a zinc plate, a plated globe valve. What happens is over time, with the condensation and the difference of material with the plating, the valve will start to pit, and you know, you might, it's no use to change the internal packing if the valve is pitted. So the best is to have a low concentrated zinc alloy in the valve body's composition, so the casting itself. So the best is bronze, because you know, let's say as we've said earlier on, to every valve its application. Let's say with chlorine, before I've seen the results, the actual studies, when chlorine is involved, will the bronze or the stainless last longer? In the chlorine application, what do you think, Mark?
I'm not sure, actually, in a chlorine application. I'm thinking the stainless steel would, but
That was my first thought, but I was wrong. The bronze will last longer. But your best, when you're dealing with either a chlorine or anything related to agriculture, farming, you need or if you want to go to the spa, you can use a motorized plastic valve. Well, actually, it's a UPPVC, CPPVC, depending on temperature rating you're after. But the plastic valve will last compared to a stainless steel ball valve or a bronze ball valve. So my first thought was because I have the chance to, my father's a chemister, so I've been handling chlorine since I was a young pup there. So, but I thought the plastic would last longer. Stainless second, bronze third, but it was bronze second, stainless third. So, but before I saw the actual results, I would never have bought any of that. But yeah. So
Kyle was kind enough to supply me with the what ANSI stands for. It's American National Standards Institute.
And correct.
So what in my experience, where 200-pound or 300-pound class valves are critical, is when you're working in a high rise and you have high head, those control valves, the bigger control valves,
reliable
on the bottom of the stack are under a tremendous amount of head pressure. And so if you'll find, if you attempted to use a 125-pound class valve in that application, you're going to have a disaster. And you know what? They look identical for the most part, but it does matter whether it's a 250-pound class valve. You can put just about anywhere. A 125-pound class valve, you better be careful where you put it, because it will not withstand the kind of pressures that a high rise will put on a
The
valve.
pressure head,
Yeah.
we've spoken about flow. If there's a hammering issues in your, when the valve opens or closes, check the side of the valve. If it follows the right side of the flow, because if it's installed reverse, what's going to happen is that the internal packing, hold on, will just gonna put a packing back, guys.
This is an excellent point, so pay attention, guys.
I'm just gonna remove the flushing cap, very important to flush your cap, verify the filters if you're ever dealing with the globe style. So the internal, what's gonna happen, instead of flow coming in this way, and you know, the piston is like a sink faucet, gonna go up and down. So if the flow goes that way, the wrong way, what's gonna happen, the flow will create velocity and will create hammering. So until it's fully closed. So that's one of the thing, you know, you remove your actuator. That's the thing that's good about the globe. You remove the actuator. Okay, it's not closing enough. I'm gonna just press on the stem, make sure it reaches. If I feel that the flow stop, I know it's not the packing that's being the problem. So there I go to the control portion. But if you go close and it's gone boom, it's really the valve, the flow is the wrong way. If it's a ball valve, that would not be anything to consider. So it's really the first thing you do on site when you go on a service call. You check on the nameplate of the valve that's there. What kind of installation is there? Is it a fan coil, the connections? That will save you lots of time and help to make the end user happy a lot faster there.
So, yeah, so if it's banging, chances are it's installed in backwards. And
Yeah.
so I'll just say after having done many startups, the last one I did, I only found 3 valves that were in reverse, but which was the best I'd ever seen, actually. But one of the other things that I wanted to just cover here, because we're running short on time, and this is important, on throughway valves, one of the most common things for me to find in a startup was 3-way valves installed backwards. And so with 3-way valves, as we know, that there is a diverting installation and a mixing installation. So I'll leave it up to you to describe the difference, because this is critical.
I told you guys valve world was not a fancy world, but here's the gold-plated valve, guys. And it's true, it's gold-plated. So as Mark said, most common thing, this is designed as a mixing. So first thing you'll see, that's a pressure number here. And it's related to the pressure that you can sustain. But the best would be to see a DN. That's for diameter. So that's really the information along with the ANSI rating that you should write down on site when you do a service call. So let's go back to the arrows now. So this is a mixing type, which means we have a most common mistake I see with the 3-way valve is, you know, mismatching, mixing, and diverting. But the simple way I want to, and a fun way to talk about valve, you know, you have a valve. So this is a mixing valve. So you have it's like a party. So there's an inlet in one end and another inlet on the other end. They mix up together, boom, they go out together, all together at the other end. A different type of valve would be, since we're talking about ports, most of the time they'll be identified saying B as a bottom port. AB would be the common port, and A would be another inlet port. So if you're using a mixing valve, diverting style, it has to be on off. Modulation will not do a good job, because what will happen, you see when the U cup moves up and down, when it's in the middle, it could rattle if you're modulating. If you're just doing two position, no problem to use a mixing valve in diverting type. The important thing is to come in by the outlet, and either you go straight or you go to the bottom port, which would be most of the time the bypass. Because when the valve, the three-way valve is installed before the coil, most of the time it's a diverting type. After the coil, you're dealing with a mixing type, and I would say 80% of designs and application. So if you have to make a change, I was taught that if you want to switch mixing to diverting, it's no rocket science there. Where there's a valve, you just put a T, and where there's a T, you put the valve. And that way you'll switch to mixing and diverting, because you need a T somewhere. It's just to switch that in the design, and that can make a quick fix for you guys.
Mhm.
So it's really, and the diverting, as I said, with coming back to my party story. So the mixing, the hot one comes in the bottom, the cold one, and they mix and they go out together. But when they're diverting, well, they all come in together, then there's something going on, and one goes one way and the other one goes the other way. They're diverting. So when you look at a three-way valve, it's very important to figure this point out, especially if you're modulating. And yeah, if you guys have any question on this one, but that's a quick way to make a fast ID on the problem or service call you're gonna go through.
I know that, I mean, it'll still work, but it won't work as well, because like you said, it becomes an on-off application. But probably I would say that was from a pipe fitter plumber's point of view, the most common mistake, whereas they didn't understand how to pipe a mixing valve properly. And even if it got to the point where when I was supplying a valve, I would draw a picture on the box. That still didn't work. But at least I tried. Then I could pick up the box and put the picture of the box up there and explain to the guy the flow. Once they understand how the flow works, then it's no problem. But you're right on the diverting thing. If you're looking for a T, that's sort of a giveaway. But anyway,
you can
fan
change
coils,
the design.
Lots of fan coils and ceilings piped wrong and been sitting like that for 25, 30 years.
Yeah. And other systems, they last forever, as we've mentioned, but it all comes down to that application valve. So
So I know that we've got just a few minutes left here, and then maybe we can, for those of us who want to stay later and chat about some more goodies you've got there.
Yeah, it's thank you guys. It's been a real pleasure for me to. I mean, I could go on, and I'm glad that we still have a Canadian team running for the big cup there. So and we were able to get rid of the Jets. That got rid of the Oilers, although the Flames didn't make it. But with all the respect I have for you, Mark, thanks again. It's been a real pleasure.
And like I said,
me.
we'll stick around for a few minutes if you got a couple of minutes, so we can continue chatting a little bit here. But I know for anybody that has to get away, then because our hour is up. I have one last very important thing that came up quite often in my career. As a general rule or observation, the control valve size is one pipe size smaller than the pipe size of the loop, generally speaking. And again, people did not understand why that is. They want to put a 3/4 valve on a 3/4 inch pipe. And then again, the answer is it's all about flow.
Yeah.
And understanding valve authority and understanding flow coefficient. All of those
pressure drop.
things, pressure drop. That's why I mentioned valve authority. It refers
exactly
to
as you've seen in European products. I mean, and another mistake I've seen lately throughout the past 7 years is contractors bringing in stuff from Europe, and when the installation is done, they filled in the system, everything leaked. And there were BSP threaded, British standard pipe threaded. So they were not 10 PT threaded. So sometimes some contractors unfortunately will try to go the fast way, but they didn't do their homework properly. So
and that coupled with the flow rates being different in European design than North American design. It's so you have to understand all of that. So if you're selecting a valve that is, you want to make sure that the engineer who laid out the piping flow design, that you're meeting what he designed to with the valve
exactly.
application.
It's like the sheet of metal example with the hole in it. What's the valve doing in between? It's working for nothing. So it's all down to selecting the proper control valve for the flow. But as you said, people find it strange. Oh, how come that valve is so small? And you have a 4-inch line, and you see an 1.5 inch valve. I mean, if you have 35 GPM going through the valve, there's no point putting that, because especially if you're modulating, you'll never reach that perfect curve on the control side. So
so I just wanted to point that very obvious thing to people that are new to the industry, that so typically the valve is one pipe size smaller than
if you ever go to a job site and you see it's a modulating valve pipe side, and you're having issues getting that perfect set point, the valve is too big for the flow and what you're out to do.
So another thing that I wanted to sort of mention, so bear with me guys here, I'm yapping, but and that's to do with the piping kits that you have available that are handy, and I know from experience. So if you are putting a new control valve on, you might consider the piping kit, because in the piping kit will be some features that ordinarily you wouldn't have room for when you're doing your piping. So I mean, I just wanted to point out that that's something to consider. Whether it's a drain or peach plugs or exactly what it is. Anyway, I just wanted to throw that in there. Isolation valves with a drain is another, huge thing. That's all pre-made, and all you gotta do is slap it in. It's beautiful. So and I'm not selling for Spartan. I'm just saying the reason why that you have these things available is, I know from experience, is that it's what other people have found invaluable in the field, and you've just made it into a manufactured product, and that's awesome. And another thing that I wanted to bring up was hydro balance cartridges, and this is to do with valve close off. And so where you would use a hydro balance cartridge, and it would be a cartridge that would fit into a standard valve.
Standard zone valve, yeah.
And it provides a higher close off because it uses the system pressure to assist the close off, I guess, is the explanation.
Yes, you do remember well the time we've met the first time at the Cyfex West in Calgary. When was that? 2014, maybe 2012. I don't remember, but yeah, that pressure chamber. We use the system's pressure, even with the thermostatic actuator that will give you, let's say, a close off of maybe 25 pounds at the most. You can reach up to 100 pounds. Same thing with the Thermoelectric. That will give you maybe 45 pounds at the most, depending on if you're using a 3/4 or 1/2 inch on that side, because the 1 inch Spartan manufacturers comes with the balance cartridge to ensure we reach that high close off compared to the pallet valve, which sometimes will not have that.
Yeah. And so I think, and correct me if I'm wrong, you can get close offs, as high as 100 PSI. Now, I can't think of an application where you would need that, but
there you go.
But they're probably out there, because especially on buildings that have been retrofitted and changed and
new pumps, yeah, they use a variable, they sometimes it can be can be puzzling. Anyway, this is why we're here.
Yeah, I personally have found use for that. I just wanted to let you know that I have run across that. And I've also when they first came out, I used to do a lot of building retrofits, older buildings and retrofitting them. And so I love the PIC-V valves, and so that's a pressure independent valve. And correct. And I guess, well, I'll let you. You're the valve expert. Maybe you want to talk about what the application for that would be.
Unfortunately, I don't have a sample on hand, but what's the great feature on this type of product? It's based on the European design, so it's really to combine, make things smaller, because heating cabinets are getting smaller and smaller. So what we offer is a pressure independent flow control combined with the actuator on the same unit. But it's really a specific product when the guys, they know what they do. It's not something that the guy will walk around with his bucket and install, and the control guy comes afterwards. So Yeah, but it's a great product, I find, because it really combines everything. And you get quite a very precise control on the temperature itself. And you have the flow control regardless of the pressure change inside the internal system, whether a pump starts or anything like that. So
Yeah. You
it's
get
really
differential pressure problems, yes, and it
Yeah.
helps with that. And another where I ran into it, and I'm just sort of winging it here. You know,
the
when-
important
when
thing
it-
I need to pinpoint on this one is, again, to flush the system properly.
Absolutely.
It's really
and,
all
and
to
don't try
this.
to put filters in. No.
No. Or try to fix it with WD-40 there.
Yeah.
Oh, it's not, it's sticking.
Yeah,
Because
no,
a common thing that I've seen on globe valve, since you guys all deal with commercial buildings and residential buildings, is that, you know, when the valve is stuck, the worst thing, if it's a globe style, don't put a PDM, because it will open, but afterwards the EPDM will expand or retract depending on what you're using, and it's really it's a quick fix, you think, but you're running after problems.
So, you know, another thing that I ran into doing retrofits again was, I know that when you have, say, a 3 or 4 story building, and you'll have different pressures on the loops on each floor, so you can do some pressure compensation, if you like, on each floor.
Yeah,
Yeah, and so it's either you go and wholesale change a whole bunch of valves out, or you put a fix on, because what happens is you don't have proper close off, or
yeah,
some valves are operating a little under their
rating, but it all
rating, and
comes
some
to
a
the
little
first
over.
question: what's the problem? Is it overheating? Not cool enough? And
So
there
what-
you have a quick, you know, a quick troubleshooting path to follow. And with that, you're able to, and when you reach the point where you realize, oh, the valve is done, there, try to find the manufacturer, what's the application, 2-way, 3-way. Is the party mixing or diverting?
Yeah. And I guess what the point I was trying to get to is I think you guys call yours measure flow or something like that, but they're pressure independent valves that just control. They're like a pressure control device that you can combine with a valve or put in a loop.
Correct.
That'll kind of dial things down so that your
Maintain
valves can operate
the
right
same
range.
flow to the fan coil or any device you're using.
Well, I hope everyone has enjoyed this. I see we still have, let's see what we got left here.
Oh,
Well, we still got a few people, but that's okay. I hope
thanks to everyone.
has enjoyed our little, and I guess you can always get a hold of Luke.
Yeah.
He's a phone call away. So
Visit our website. You might make the mistake sometimes because there's a company in Calgary named Spartan Controls, but we're not related to them. So we're Spartan Peripheral Device out of Montreal, and yeah, we'll be happy to help you out.
yeah, so the phone or the website is www.spartan-pd.com.
There you go.
And again, a Canadian company, so I'm putting the plug in for a Canadian company. Even if you are a Montreal Canadian fan, I must say, you know,
But I would have cheered for the Jets if
But
they
now that
would
you've
have
won
won.
Canada, it means you got to go all the way. 'Cause
There
there's
you
no
go.
other
The
way
cup
now.
gotta remains up north, you know? It's all about control.
That's right.
It's
Okay,
our game.
there you go. We'll leave you that. Thank you very much, Luke. It was
Thanks to
enjoyable.
you. It's been very pleasant for me, and can't wait to meet you again at the next SciFex West in Calgary when things will make it possible. So
Yeah.
thanks again.
So
And,
looking forward to that, and maybe when we have our own next little trade show coming
Yeah.
up next year, maybe either this fall or next year, maybe you can get in on that. Who knows, right? I'll have to
Yeah,
I'll phone you up and give you a hard time, but anyway.
no problems anytime. You're the
All right,
man.
thanks, man, Luke. And we'll probably be taking a little break for the summer here. And then our next meeting, official meeting, is going to be, other than executive meetings, will be in September. So anyway, thanks guys for the putting up with the weird webinar thing and the Zoom stuff, but best we could do in trying times. And thanks again, Luke. I'm sure you're having lots of COVID challenges too. So, oh my God, we'll get through it. And looks like if things go the way they are, we should be good by September. I'm hoping anyway. So
Hopefully, and the only thing I can say is let's continue to go through all these hard times, but no, keep the high spirits. And
Yeah.
thanks again. It's been a pleasure for me, guys.
Okay then. Bye-bye.